Alright, so this time we're factorising over c again, but this time we've got like a higher polynomial. So we've got 6z to the 4 plus z to the 2 minus 1. Now, this is a pattern you'll see semi-frequently. Z to the 4, z squared. Now, when you see that, alarm bells should go off. Now, we can rewrite this as a quadratic if we let z squared equal any letter. Let's call it w. Alright, so if I let z squared equal w, then if I start from the left-hand side, the right-hand side, we've got negative 1. Z squared is going to be w, and z to the 4 is going to be the same as w squared. So we've got 6w squared plus w minus 1. Now, just double check this. W squared is the same as z squared squared. So w squared is equal to z to the 4. That's why we've put w squared in here. Alright, now we've got 6w squared plus w minus 1. We can factorise that. Depends on what sort of methods you've learnt for factorisation in the past. I use something called decomposition or the AC method. I know some people have called it splitsies in the past. Basically, we take this A value and this C value. We do 6 times negative 1. That's equal to negative 6. And then we need two numbers that when multiplied together make negative 6 and we make 1. Alright, so the two numbers that will do that are negative 2 and 3. Negative 2 and 3. That means that we can decompose the w. So we have 6w squared minus 2w plus 3w minus 1. We can factorise the first two terms. So common factor here is going to be 2w. That's going to leave me with 3w here and minus 1 here. Repeat that factor, so it's going to be 3w minus 1 again. And 3w minus 1 times what makes 3w minus 1? Positive 1. And then I can put 2w and positive 1 in their own set of brackets, and we end up with 2w plus 1 times 3w minus 1. Now, if you've got a different method for getting from here to here, by all means do it. Some of you might know the cross method, some of you might know some other methods, but you just need to get down to here. Alright, once we're down here, let's do some more work. Now that I know that 2w plus 1 times 3w minus 1 is this in factorised form, I can sub my zw back in. Z squared back in. Sub z squared back in. So that's going to be 2 z squared plus 1. And then 3 z squared minus 1. Now it's at this stage that you really need to take a look. Now 2z squared plus 1, that's not a difference of 2 squares, so it doesn't really work for us. 3z squared minus 1 is. But we can turn this into a 2z squared plus 1 by replacing this plus 1 with an imaginary number, with an I squared. Alright, let's do that. Now this 2z squared plus 1, that bit there, that plus 1 can be written as 2z squared minus I squared. So we're really looking for an opportunity to put that I squared in there. There's our opportunity. 3z squared minus 1. And then from here, each of these brackets is a difference of 2 squares. So 2z squared minus I squared. The difference of 2 squares here, I'll just use a different colour pen. That's going to be root 2z plus I. Root 2z minus I, and this is going to be root 3z plus 1 root 3z minus 1. Alright, there's our factorisation. Quite a bit of work to do here, but notice these. Let w equal z squared. Let z squared equal w. Work through it, factorising it however you factorised it in the past. Sub your z squared back in. You're looking for a plus 1, so you can turn that into a negative I squared, and then factorise from there.